There are some equations that can be solved by substitution, and the substitution to be used is suggested by the equation itself. As an example, supposing that we are given the differential equation y prime is equal to 9x plus 4y plus 1 quantity squared. We first write the equation as dy dx all over equal to the quantity 9x plus 4y plus 1 quantity squared. In this equation, we can simplify this by letting c be equal to 9x plus 4y plus 1. So we are introducing the variable c in the equation. And naturally, there will also be a change in the differential. So taking the differential both sides, we have dc equal to 9dx plus 4 dy. Let us solve for dy. dy is equal to dz minus 9dx all over 4. So we make the following substitutions to our equation. dy becomes dc minus 9dx all over 4 equal to, let us cross multiply, we will be getting c squared dx, or dc minus 9dx equal to 4c squared dx. So dc is equal to, let us transpose negative 9dx, so 9 dx plus 4c squared quantity dx. Obviously, this equation is such that the variables are separable. So we divide by 9 plus 4c squared. dc over 9 plus 4c squared equal to dx. And then we integrate. So integrating dc over 9 plus 4c squared, it is of the form a squared plus u squared, wherein your u is 2z and the differential is 2dc. And for du over a squared plus u squared, the integral is 1 over a, or 1/3, and then times 1/2, because the differential of 2c is 2dc. So 1/2 arctangent of 2z all over 3 equal to x plus the constant c. Right? We can use here c all over 6. So multiplying everything by 6 will get arctangent of 2c over 3 equal to 6x plus c. And then taking the tangent, we have 2 over c over 3 equal to tangent of 6x plus c, or 2c equal to 3 tangent of 6x plus c, and our c is 9x plus 4y plus 1 equal to 3 tangent of 6x plus c. Right? Another equation that can be solved by substitution is a Bernoulli's equation. A Bernoulli equation takes the form dy plus p of xy dx equal to q of x y to the n dx. You'll notice that this expression is almost the same as that of a linear equation or a linear equation in y, now except for y to the n. Striking up y to the n, it becomes linear in y. It's a linear equation in order 1, no, in the variable. Linear equation of order 1, no? Or linear in y of order 1. So, let us see what will happen if we are going to divide both sides of the equation by y to the n. So divide both sides of the equation by y to the n. Okay, so what we will get is y to the negative n dy plus p of x. Y over y to the n will be y raised to 1 minus n dx equal to q of x dx. And then we introduce the variable z equal to y raised to 1 minus n. Again, if we are to introduce a variable, there will be a change in the differential. So taking the differential of both sides, we have dc equal to 1 minus n, y raised to 1 minus n minus 1 or negative n dy. Okay, or dc over 1 minus n equal to y to the negative n dy. So y to the negative n dy is your dc all over 1 minus n. So it becomes dc over 1 minus n plus p of x, and your y raised to 1 over n is your z dx equal to q of x dx. 1 minus n is a constant, so we multiply everything by 1 minus n. 1 minus n, p of x c dx equal to 1 minus n q of x dx. And we recognize this as a linear equation of order 1 in the variable c. Okay? 1 minus n, p of x is a function of x. Notice that c appears separate from the dc. So, if this is a linear equation of order 1, we know how to arrive at the solution of this equation by calculating for the integrating factor p. Okay? So, once we have transformed a Bernoulli equation into its equivalent linear equation of order 1 in the variable c, we know that the general solution here will be Bc equal to the integral of the integrating factor b 1 minus n q of x dx. So let us have an example. Solve the equation y prime equal to y minus x y cubed e to the minus 2x. So we write y prime as dy dx equal to y minus xy cubed e to the minus 2x, or dy equal to y dx minus xy cubed e to the minus 2x dx. Dy minus y dx equal to negative xy cubed e to the minus 2x dx. This is almost linear except for the power y cubed appearing as coefficient of dx. So we divide by divide both sides by y cubed. So y to the negative 3 dy minus y to the negative 2 dx equal to negative x e to the minus 2x dx. Okay, and then let z be equal to y to the negative 2. So dz equal to negative 2y to the negative 3 dy. And y to the negative 3 dy becomes dz all over negative 2 minus y to the negative 2 is c, and then dx equal to negative x e to the minus 2x dx. Multiply everything by negative 2 will give us dz plus 2c dx equal to 2x e to the minus 2x dx. So this is now linear in the variable c. So the integrating factor b is exp, the integral of 2 dx, which is equal to e to the 2x. So we know that the left side, by the introduction of e to the 2x, becomes exact, which is equal to c e to the 2x. No? Differential of c e to the 2x equal to, we then introduce e to the 2x to the right side dx, and we know that e to the negative 2x, e to the 2x is 1. So we then integrate. The integral of the differential of c e to the 2x is c e to the 2x equal to 2x dx, or 2x squared over 2, or just x squared plus the constant c. And our c is y to the negative 2. Our c is y to the negative 2, or e to the 2x over y squared equal to x squared plus c, or e to the 2x equal to y squared times x squared plus c. Okay? Let us have another one. Six, okay, 6x squared dy minus y 2y cubed plus x dx equal to 0. So let us divide this by x squared. Divide everything by x squared. So 6 dy minus 2y to the fourth. Okay, let me change the color. 6 dy minus 2y to the fourth all over x squared dx minus 6 or xy over x squared or just y over x dx equal to 0, or 6 dy minus y over x dx equal to 2y to the fourth over x squared dx. Okay, then we divide by y to the fourth. Divide both sides by y to the fourth. So we get 6y to the negative 4 minus y to the negative 3 over x dx equal to 2 over x squared dx. Then we introduce c equal to y to the negative 3. So dz is equal to negative 3y to the negative 4 dy. Okay? So what will happen, by the way, there is a dy here now. Dy. Okay? So y to the negative 4 dy is dc over negative 3, or that would be negative 2 dz minus z over x dx equal to 2 over x squared dx. Or equivalently, that will be positive 2 dc plus c over x dx equal to negative 2 over x squared dx. And then let us divide everything by 2. dc plus c over 2x dx equal to negative dx over x squared. And we know that this is now linear in C. Okay, so our integrating factor v is equal to exp of the integral of dx over 2x. Okay, integrating, we have exp 1/2 of ln x, or exp ln x to the 1/2, but the exponential of the natural logarithm of x to the 1/2 is x to the 1/2, or the square root of x. So that being the integrating factor, we know that the left side will become the exact differential of c square root of x. And then the right side, we introduce the square root of x over x squared dx. No? So introduce to the right side the integrating factor square root of x. And we know that that is equivalent to negative x to the 1/2 over x squared is x to the negative 3/2 dx. So we integrate, that will be square root of c square root of x equal to negative, the integral of x to the negative 3/2 is x to the negative 1/2 over negative 1/2 plus c. So what happens here becomes c square root of x equal to positive 2 over square root of x plus c. Okay, so let us multiply by square root of x. That becomes c square root of x times square root of x is cx or xc equal to 2 plus c square root of x, or xc minus 2 equal to c square root of x. I want to further simplify this, so let me have some space here. Okay, so to continue, xc minus 2 is equal to c square root of x. Let me square both sides to get rid of the radical. So what I have here is xc minus 2 squared equal to c squared x. And what is my z? My z is y to the negative 3. Now remember, our c is y to the negative 3. So x y to the negative 3, or x over y cubed minus 2 squared equal to c squared x, or x minus 2y cubed squared over y cubed squared is y to the 6 equal to c squared x. So finally, we'll get x minus 2y cubed quantity squared equal to c squared x y to the 6. There.